Hello everyone! Today, I'm going to show you how I transform an ordinary USB wall charger into something truly extraordinary. A powerful DIY antenna that will pick up free TV channels. I'm using a small screwdriver here to pry it open without damaging the casing, as we'll be reusing it. Once open, you'll see the internal components. We're removing the internal electronics because we only need the external casing for our project. I'll use a ruler to measure and mark precise points on the casing. This step is crucial for ensuring all our new components align correctly and securely. I'm marking specific locations where I'll drill holes, which will later hold our antenna elements. For the next step, I'm supporting the charger on a wooden block underneath to prevent it from cracking and to ensure a clean drill through. I'm going to use a drill to create several small holes in the plastic casing, following my markings. These holes are essential for mounting our antenna components later on. Next, I'm taking some copper wire. To create perfectly circular coils, I'm using a WD-40 size 70 milliliters can as a guide. This ensures my loops are consistent in size and shape, which is important for uniform signal reception. After coiling, I'm cutting the wire into individual rings using pliers, creating several progressively smaller loops. To make a larger ring, I used a 191 milliliters bottle of WD-40 as a guide. With the wire coiled, I'm now using my pliers to snip the wire into individual loops. Cutting them precisely ensures that each loop contributes evenly to the overall signal reception. I repeated the rolling and cutting process with an identical piece of wire to create a third round, this time using a 412 milliliters WD-40 bottle as a guide. These varying sizes will allow the antenna to pick up a broader range of frequencies, improving its overall performance. Now, I'm ready to integrate these into the charger. I'm now carefully inserting the smallest copper ring into the charger through the holes I drilled earlier. I'm bending the ends of the wire on the inside of the charger to secure it in place. I'm using a hot glue gun to firmly secure them into the pre-drilled holes. This creates a balanced and effective antenna array. You want to make sure the loops are evenly spaced and positioned correctly for optimal signal capture. The hot glue provides a strong, quick bond, holding the loops in place. Then, I'm repeating this process with the next size up, attaching it slightly above the first one, making sure they're aligned. With the inner rings in place, I'm using a hot glue gun to secure them firmly inside the charger. This prevents any movement and ensures a stable connection for optimal signal quality. I'm applying glue generously around the points where the wires pass through and where the rings touch the casing. Now I'm taking one shorter piece of wire. I'll carefully strip the insulation using my wire strippers. We need the bare copper wire for electrical connections in the next steps. I'm now connecting these smaller stripped wires to the main antenna loops. I'll carefully twist the bare ends of the smaller wires around the base of the loops, ensuring a secure and conductive connection. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. I'm stripping the ends of some insulated wires, one blue and one brown, to expose the copper. These will be our main connection wires for the antenna. Using pliers, I removed the plug pins of the charger. I'll drill 2 small pilot holes into the charger casing, close to where the original prongs were. Then I'll thread the wires through and secure them with plug pins, ensuring they are tightly fastened. These will act as the new power input for our antenna. This allows me to properly route and connect the antenna wires, ensuring a clean and functional setup inside the reused casing. Now, for the internal connections, I'm preparing a tiny SIM card chip and carefully trimming it down to size from its plastic backing. This will serve as a small base for our internal wiring. I'm now applying a small amount of solder to each of the exposed contacts on the SIM card chip. This prepares them for connecting our wires. I'm using a soldering iron to attach the ends of the blue and brown wires to specific points on this trimmed plastic card. The soldering creates a strong, permanent electrical connection, which is vital for signal integrity. This chip will act as a signal amplifier, boosting the incoming signals for a clearer picture. I connected the brown wire I just soldered from the SIM card to the brown exposed wire from the charging port. To ensure maximum insulation and prevent any accidental contact, I'm carefully wrapping all the exposed wire connections with electrical tape. I'm connecting the blue wire from the circuit board to these pins, securing them firmly by twisting and bending. This ensures power flows to our antenna system. Then I used pliers to strip the insulation from both wires from the charging pin. To complete the circuit, I soldered these two wires to the loops from the inside. Use paper clips and pliers to make a stable and sturdy soldering stand. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. Once all the soldering is complete, I'm housing the small circuit board back inside the charger. I'm gently pushing the components into place, making sure nothing is pinched or misaligned. Then, I'm carefully closing the charger casing, securing it with the original screws if possible. You can see the antenna coils extending from the top, ready to capture signals. To complete the antenna, I'm preparing a power outlet that sits on a small wooden base. Using a screwdriver, I opened the cover of the socket. The electrical pins were exposed. This is where the antenna connects. I need to access its internal wiring. I have a long coaxial cable, and I'm stripping the outer insulation to expose the inner conductor and shielding. These wires will carry the signal from our antenna to the TV. Now, I'm connecting the stripped wires of the coaxial cable to the internal terminals of the wall socket. I'm using the screwdriver to tighten the screws, ensuring a firm and reliable electrical connection. This integrated design makes the antenna compact and easy to use. The power cable extends from the back, ready to be plugged in. With the wires securely connected, I'm reassembling the wall socket, screwing the faceplate back on. This keeps the wiring safely enclosed. I'm stripping the other end of the coaxial cable, then the braiding, and finally exposing the inner conductor. This is a critical step for preparing it for the antenna connection. I'm carefully attaching a coaxial F connector to the stripped end of the cable. This connector provides a standard interface for connecting to televisions and other equipment. Now for the final assembly. I'm carefully attaching our newly modified charger, with its coil antenna, into the custom wooden power outlet. This entire setup creates a ready-to-use, homemade TV antenna. Initially, I see a no signal message, which is expected. I'm connecting my newly built antenna to the TV. And just like that, channels start appearing. Look how clearly the picture comes through. This proves our recycled charger antenna is working perfectly. It's incredible to see how a little ingenuity can bring new life to old items and save you some money too. Using the TV remote, I navigate to the channel scanning menu. This process allows the TV to search for and lock onto available broadcast signals from our custom antenna. As you can see, the TV is now receiving multiple channels with crystal clear reception, all thanks to our DIY antenna. This works perfectly, giving me access to free over-the-air broadcasts without a bulky traditional antenna. To emphasize the point, I'll temporarily disconnect the antenna again. See, no signal. This proves that our DIY antenna is indeed doing all the work. And just like that, reconnecting it brings back the perfect picture. It's a simple, effective solution that anyone can build at home. I can now easily flip through various channels, all thanks to this simple DIY project. The signal is stable, and the picture quality is fantastic. I hope you enjoyed this transformation. If you found this video helpful or inspiring, please give it a thumbs up, share it with your friends. Don't forget to subscribe for more creative ideas and hit that notification bell so you don't miss out. Thank you for watching, and I'll see you in the next one.